Okay, problem posted May 5th for the Math Contest 3.0. I don't see any solutions for these online, so I'm going to start posting them, but that is the problem. And first off, this reminds me of, I think they're called Einstein problems. I've seen a bunch of math exams. Like, they give you a bunch of information, and basically you have to, extrapolate from that information. So, first thing we're going to see here is, let's just write this out. If you look at it closely, first two ones are very important, AACA and ADDDD. That's too many D's. We can get from this that C cannot equal A, because if so, it'd be divisible by a whole bunch of stuff, and A cannot equal D. We also get from this that D cannot equal C, because in the third one, if D equaled C, it'd be a palindrome, and palindromes are, even palindromes are always divisible by 11, so C cannot equal D. And since these are prime numbers, we know that neither A, nor D, nor B, nor C are the numbers 0, 2, 4, 5, 6, 8. And so that's pretty substantial. That's what we have so far. And so that just leads these remaining numbers to figure out. And if you look at it closer, from those last two terms, we can see that D is greater than C. And we can also see that not A and C or A or B cannot be multiples of 3, because then it'd be divisible by 3. Let's just write that down. A plus C cannot equal 3, or A plus, by plus I mean like an and operator, not actually plus. Like that. So they can't be multiples of 3. Now this leads to something interesting. The only numbers we have left are 1, 3, 7, 9. Now if A equals, I don't know, let's say A equals a multiple of 3. Or no, let's say A equals 1. No, it needs to be multiple of 3. I was right the first time. Well then, we know that C can't be a multiple of 3, but neither can D. And D must be greater than C, which means that A can't be a multiple of 3, and since two things are greater than A has to be 1. So we can write this down here. As soon as I get this, A equals 1. That's why I turn our attention to the kind of relationship. Since the last one is bigger, that means that B is greater than A. And it means that if C from the last two, that D is greater than C. Oh shoot, I already have that. Well, D is greater than A. So we have A is equal to 1. And from there, we can go back to those first two terms, because that was a lot of A's. Look, AACA. Let's write that down. 1, 1, C, A. Now, oh, well, A is 1, we know that. What can C realistically be here? Well, it can be 3, it can be 7, but it can't be 9, because one thing is greater than C. So, well, if it's 3, let's just do a quick little modular arithmetic. This is equal, if C was 3, this would be equal to 1,000 plus 100 plus 3, which you know is divisible by 3, so I don't have to put it. I'm just going to put 30 plus 1. Now, this is 1 modulo 3, this is 1 modulo 3, and this is 1 modulo 3. So C can't be 3, so C must be 7. Let's erase this. Is D and B. Now, do we have anything here that could kind of say, well, D has to be greater than C. So that means that D must be equal to 9. And B must be equal to 3. And so the number BDAC must be, well, B, D, A, I don't mean to write A, C. If we scroll down, because I worked it out beforehand, I didn't just do it, 3917. 3917. And that's how you do this problem, May 5th, from the Math Contest 3.0.